I want to show an example with a packer. In this case, Vmprotect, where the driver or the malware or whatever isn't just storing raw pointers in their data section from dynamic loading. So here I have the code. Ignore this. This is just to actually find where the code is. I'll just give an example, right? If you look at the imports, get current thread is not here. And get current process ID is not here. Some of them will show up. Vmprotect won't hide those. I'm pretty sure because it's the free version. I don't know. Whatever. Now, if we look at the code that is doing these calls, right? These calls do not only do they not say the symbol name, but the actual value points to a stub, right? Remember I said in Packers the data section won't have raw pointers to kernel addresses or user mode addresses, and you cannot just dump them nicely with um, what's it called, WinDebug. Now, instead, what they do point to are stubs. Now, this is this. Now, if we look at this call, this points to a stub, which does nothing, jumps, does nothing, jumps, does nothing. Oh, wait, yeah. Okay. Now, if you look at this immediate value that's being loaded into RPP, right? So this is the value of the pointer which is being loaded into RPP. Now, boom, right? Now, if you go further into the stub, it takes that value and subtracts it by this, which I've already done the math for. And then it exchanges it with RPP and pretty sure just returns. Yeah, returns. Okay. Now, after you decrypt this, right? Quote unquote decrypt. I guess I should say deobfuscate. What you can do is you can get Unicorn. Unicorn is a interpreter. It actually runs the code. You can walk through. Where's the shit? Okay, you can, like, in this example, you can walk through the Z section. Is the Z section? No, I'm tripping. I'm sorry. Sorry. Yeah, no. The Z section. Yeah, what am I saying? This would be hard to program. Back in the days, Vmprotect used to be much easier to reverse, but or at least interpret. It's still easy to reverse, but you can walk through the stub with Unicorn. You can interpret the code. You could actually here, I'll show you another one. Let's see this one. Jump. We're gonna take this. Go here. Now this immediate value is loaded. We're gonna see the value on this. Are we fucking for real? Why is it D? Okay. Like this one. We're gonna let that in here. Then we're gonna go back to the stub. See the logic on it. You can have Unicorn literally emulate all of this. And pump out the calculated address, right? This one is a little complicated, I can't lie, because I don't think this is right. Okay, that definitely does not look like a... Maybe that's not a real call, I don't know. Let's look at another one, like this one. Immediate byte value. What the hell just happened? Okay. D. Yeah, but yes, I want to convert it to data. Fuck. Okay. So we'll take this one. Paste it in here. Go back to the stub. Right. Decrypt this or deobfuscate, whatever, and you get an address back. I'm pretty sure that's a real address. It's not any of these ones, but here, let's see. Let's try the other one. I'm just doing this on video, anyways, just to show you. Maybe this one. Jump. Go here. Take this one. paste. Look at the logic. Alright, there we go. Matches this one, right? So, where was I? Anyways, my point is that this is another thing you'll see with Packers is the calls will be calling someplace that points to a stub, and that stub will actually return the actual address that it is calling, the actual decrypted address. Now, I guess that's what I wanted to show you, yeah. I want to show you how Packers call global pointers, but the point is that you cannot just walk the data section and look for raw pointers. They will not be stored globally. Instead, what you will have to do is you will have to walk the section which the stubs are stored in, which in this case is the Z. You'll have to emulate that stub with unicorn, for example. And once the decryption is done, which in this case, for example, is we here jump. Once the subtraction is done, usually there's an exchange. After that exchange is hit, you can even interpret it with Zidis actually. You dump the calculated address, which is stored in RBP. And then you will be able to fix your IAT. Yeah.